Good evening, dear students. So today we are going to start with the next topic. Okay, so this is the last topic from your chemistry topic, chemistry. Okay, so that is the chemical kinetics, right? So this comes under your physical chemistry. So this chapter, chemical kinetics, it comes under physical chemistry. Okay. So already we have discussed the all the theory part. Okay, in our ACE classes. So the students who have who have not watched those videos can watch those videos. Okay, so there we have explained in detail about the chemical kinetics, various concepts. Okay, various definitions, order of reaction, molecularity of reaction, rate of reaction, right? What is unimolecularity, bimolecular reaction, right? So different reactions we have discussed. Then we have discussed the different first order kinetics, second order kinetics, right? Zero order kinetics, half life, right? Uh, so what is pseudo reaction? So these all things are there. Okay. So already we have discussed. So based on that, okay. So today we are going to see some questions. Okay, we are going to solve some MCQs based on this particular concepts. Okay, fine. Uh, I hope you have revised all these concepts. Okay, so let us start with the MCQs. Okay, so these are some MCQs. So let us start. The first question is, for a chemical reaction A giving you B, okay, the rate of the reaction is 2 into 10 raised to minus 3 mole dm cube, okay, per second, when the initial concentration is 0.05 mole per dm cube. The rate of the same reaction is 1.6 into 10 raised to minus 2 mole dm minus 3 per second when the initial concentration is 0.1 mole dm cube. The rate of the reaction is, so what is the rate of the reaction? So there is a chemical reaction. Okay, so what is a chemical reaction? A giving you B. Okay, so let us see this particular question. So the reaction is there. So for a chemical reaction, okay, that is A giving you B. Okay, A is the reactant giving you product B. The rate of the reaction is given. Okay, so rate of the reaction is given as what? Rate. So let us give rate of the reaction as 2 into 10 raised to minus 3 mole per dm cube. Okay, when the initial concentration is. So how do we write the initial concentration? Initial concentration is this, right? A naught. A naught is the initial concentration, which is given as 0.05 mole per dm cube. Right. So the rate of the same reaction is 1.6 into 10 raised to minus 2 mole per dm cube per second when the initial concentration is 0.1 mole per dm cube. Okay. So the rate of the reaction. So second rate. So second rate of the reaction. So this is the first rate. Second rate of reaction is given as 1.6 into 10 raised to minus 2 mole per dm cube. Okay. Uh, per second. Here is also per second. Then what is the initial concentration? When initial concentration, that is A naught. Okay. A naught is given as 0.1 mole per dm cube. So what they have asked? They have asked to find the order of the reaction. What is the order of the reaction? So here you can see what is the rate. It is so rate is given as what? So rate is given as, okay, K, that is rate constant into 10 raised to N. So this is the rate equation for the reaction. So this is a rate equation. This is called as a rate equation. Okay, this is your rate constant. K represents what? K represents your rate constant. N is your what? We are finding the order of the reaction. Okay, and this in bracket what we write, that is called as a concentration, right? We call it as the concentration of the reactant. So the rate equation is given like this. Rate is equals to K into concentration of A raised to N. Okay. So these are the given things. Rate is given. Okay. Rate 1, that is, so these are the things. Then initial concentration. This is a rate 2. And okay. And this is the initial concentration. So let us write the rate of both the, according to, by applying the rate equation, let us write the rate equations for both. So what is rate? First one. Okay, this is first one and this is second one. So rate is equals to 2 into 10 raised to minus 3 is equals to K into what is the initial concentration? That is 0.05 raised to N. Right. So this is first equation. This is first equation. Similarly, okay, second is 1.6 into 10 raised to minus 2 is equals to K into 0.1 is to N. Okay, N. So this is your second rate equation. So what we will do, we will divide 1 by 2. Okay, what we will do, we will divide 1 by 2. Okay, I hope up to here it is clear. Okay, so rate equation, how we have given the rate equation, rate is equals to K into A raised to N. Okay, so by applying this rate equation, we have substituted both the equations. Okay, so that is 2 into 10 raised to minus 3 is equals to K into initial concentration is 0.05 raised to N is first equation, and second is 1.6 into 10 raised to minus 2. Okay, K into K into concentration of 0.1 raised to N. So this is the second equation. Now, next step is what? We have to divide. So divide 1 by 2. Okay, 1 by 2. So 1 by 2 means, so this is 2 into 10 raised to minus 3 divided by 1.6 into 10 raised to minus 2 is equals to K, it cancels. So it will be 0.05 raised to N and 0.1 raised to N, right? So find out. So this will be what? So you have to cross multiply. Okay. So just see what you will get now. So just find out. So 0.3 into 10 raised to 2 into 10 raised to minus 3. What you are try to answer? Find out the answer here. Divided by 0.016. So this will be 1.6 into. So after substituting this, okay, I'm going to get, okay, Shivaruni has answered as B. Okay, just see, I'll do it here. I hope the white screen is visible. Okay, so what we said, so rate, okay, rate is equals to k into a raised to n, right? Rate is equals to k into a raised to n. So with this, what we have done, we have applied the both the rate equation. Okay, so this is the therefore, so this is the first rate equation, that is k into 0.05 raised to n. So this is first one, and second one is 1.6 into 10 raised to minus 2 is equals to k into 0.1 raised to n. Okay, now what we did, we divided 1 by 2. Okay, 1 by 2. So what we got? So 2 into 10 raised to minus 3 divided by 1.6 into 10 raised to minus 2 is equals to k by k 0.05 n upon 0 concentration of 0.1 raised to n. So this and this get cancels. Okay. So after okay, after finding the value for this, I have got it as 0.05 n divided by 2 raised to n 2 raised to n 0.05 n. Okay, so that is 1 by, so this n gets get cancelled. So 1 by 2 raised to n, that is 2 raised to n, so 1 by 8. Okay, 1 by 8. So that is n is equals to what? N is equals to 3. So 2 raised to n is what? It is 2 into 2 into 2. Okay, 2 2s are 4, 4 2s are 8. Right, so n is equals to 3. So our order of the reaction is 3. Order of the reaction is 3. So, so here you see, so which is the option? It is option number B. Option number B. Okay, so option number B is the answer. So like this, we are going to find out the order of the reaction. So like this, we are going to find the order of the reaction. Okay, let us go for the next one. For the decomposition of, for the decomposition of a compound AB at 600 Kelvin, the following data were obtained. Okay, so this is the following data which were obtained when the compound AB has decomposed. So this is the, you can see the data. Okay, so this is the data. So you have to tell what is the order of the decomposition of AB. What is the order of the decomposition of AB? So this is the decomposition of compound AB. Okay, so is taking place, decomposition of compound AB is taking place at 600 Kelvin. So following is the data which is obtained. So data obtained is what? AB, so 0.20 mole per DMQ. The rate of decomposition is 2.75 into 10 raised to minus 8. At 0.40, the rate of the decomposition is when the concentration of A and B was 0.40, the rate of decomposition was 11 into 10 raised to minus 8. The concentration of AB when it was 0.60, the decomposition rate of decomposition was 24.75 into 10 raised to minus 8. So what is the order of decomposition? Okay, so again here what we have, three rate equation we have, right? So just now we saw what is the rate. Rate is given as k into concentration of AB into n, right? So just now we saw. So let us write the rate of all three. So 2.75 into 10 raised to minus 8 is equals to k into 0.20 raised to n. So this is the first rate of equation. Then second is 11.0 into 10 raised to minus 8 is equals to k into 0.40 raised to n. This is second rate of equation. Third one, 24.75 into 10 raised to minus 8 is equals to k into 0.60 raised to n. That is third rate of equation. So now what we will do? We will divide 2 by 1. Okay, we will divide first these two. So 2 by 1. So that is 2 by 1, 11 into 10 raised to minus 8 divided by 2.75 into 10 raised to minus 8 is equals to 0.40 raised to n and 0.20 raised to n. So what? So 0.40, find out, substitute, find out. So 11 divided by 2.75 is 4. This thing, 0.40. So it will be 0.40 by 0.2 raised to n. So that is 2 raised to n, that is equals to 2 is nothing but 2 raised to n, that is n is equals to 4. So the rate is n is equals to 4 here. Okay. So n is equals to 4. Sorry, 2 raised to n is 2 raised to n. Okay. 2 raised to n is 4. So n is equals to 2. N is equals to 2 here. Okay. N is equals to 2. So what is the order of reaction is 2. So option number C. Okay, option number C in the option number C. So this is the order of the rate of reaction. Got it? So what we have done, so there are same, how we have solved the first one. Same way we have done. Okay, we have written the rate of the equation, rate of the reaction, and then we have solved it. Okay, then we have solved it. Okay. So what we have done, so rate of the reactions of 1, 2, and 3 we have done. Then 2 by 1 we have divided. Then after dividing, okay, we have found out the value of n. That is 2. That is 2. So the order of the reaction is 2. So option number C is the answer. Okay. So the rate equation for a reaction A to B is R is equals to K concentration of A raised to 0. If the initial concentration of the reactant is a mole DMQ, okay, the half period of the reaction is. So what will be the half period of the reaction? So if the concentration of the reactant is a what? A mole DMQ, then what will be the half period of the reaction? So what is the rate reaction? So this is the rate equation for zero order. Right. So the reaction is of what? So rate equation when K, that is K rate constant into concentration of A raised to 0. Right. When concentration of A is 0, then this is a zero order reaction. So this rate equation represents a zero order. Okay. It represents what? It represents zero order. So for zero order reaction, T half is what? It is directly proportional to the A, right? Concentration of A, right? So it is directly proportional to A. So, or we can write it as T half is equals to A by 2K, right? T half is equals to A by 2K. So, what is the answer? A by 2K. So, option number D. Option number D is the answer. Yes, Lubna has answered it. Correct. Very good. So, yes, D is the answer. Which first your syllabus you asking? CET. Already PU1 CET classes are also going on. Okay. So rate equation, given rate equation is of zero order. Okay. If the initial concentration of the reactant is A, so T half is what? Directly equal to A. Right. So T half is equals to what? A by 2K. Okay. T half is equals to A by 2 by A by 2K. Okay. So this is the rate equation. So option number D is the answer. Okay. Let us go for the next one. The rate equation, the activation energy for a reaction at the temperature T Kelvin was found to be 2.303 RT joule per mole. The ratio of the rate constant to Arrhenius factor is, okay. 10 raised to minus 1, 10 raised to minus 2, 2 into 10 raised to minus 3, and 2 into 10 raised to minus 2. So the activation energy for a reaction at the temperature T Kelvin, okay, it was found as what? 2.303 RT, Joule per mole. So you have to find the ratio of rate constant to Arrhenius factor. So what is, according to the equation, it is 2.303 r 2 this is your what is that, rate constant, right? 2.303 RT. Okay, so log of K is equals to 2.303 log of A minus EA by RT. Okay, so what we will do, so this is the equation which we know. Okay, activation energy. So what is activation energy? Activation energy is 2.303 RT. Right. So what is the activation energy which is given here? 2.303 RT. Okay. So this is the activation energy which is given. Now, what we will do? We will put the values of EA. Okay. We will put the values of EA. And what we will do? We will divide 2.303 on both the sides. Okay. So what we are going to get? So 2.303 log of K, so divided by 2.303 is equals to 2.303 divided by 2.303 log of A minus EA is what? 2.303 RT by RT. Okay. So now this is what we have substituted. What we have done? What we have done here? We have, so this is the equation what we know, 2.303 log of K is equals to 2.303 log of EA by minus EA by RT. So we have, this is the given value for activation energy. So what we are doing, we are dividing 2.303 on both the side, and we are putting the value of EA in the above equation. So what we are going to get, this will cancel, this will get cancelled, RT and RT will get cancelled. What we are going to get, log of K is equals to log of A minus 2.303. Right. So what we have got, log of K is equals to log of A. Again, here also we are going to cancel, no, 2.303. Okay, wherever 2.3, so it will be minus 1. So this will be here. So what here we have not substituted. So wherever 2.2, 2.303 is there, no, that we have to multiply by 2.303 RT. Okay, so this and this also will get cancelled. So we are going to get minus 1. So log of K minus log of A minus 1. So now log, okay, log is equals to K by A is equals to minus 1. So if we take anti-log, okay, if we take anti-log, so anti-log of K by A is equals to 10 raised to minus 1. So what we have got, what we have got here, so it is option number 10 raised to minus 1. Option number A. Right? Option number A. Yes, Lubna has answered it correct. So what all things we have given? So activation energy is given. Okay. So what was the temperature found? T Kelvin. Okay. That was 2.203 activation energy. So they have told you to find out the ratio of rate constant to Arrhenius factor. Okay. So according to the ratio of that is the rate constant versus the Arrhenius factor. So that is 2.303 log of K is equals to 2.303 log of A minus EA by RT. So we have activation energy. So what we have done in the above equation, wherever 2.303 is there, we are dividing it on the both the side. So what we have got, log of K is equals to log of A minus 1. So by taking log on one side, that is K by A is equals to minus 1. So if we take anti-log, it becomes 10 raised to minus 1. So option number A is the answer. Okay, let us go for the next one. Time required for 100% completion of zero order reaction is. So what is the time required for 100% zero order reaction? 2K by A by 2K, A by K, and AK. Yes. So what will happen as the concentration of the reactant? So as the concentration of the, so what will happen? Yes, Lubna has answered it as C. Okay, so concentration of the reactant, what it will become, it will decreases. Okay, as the time, okay, as the time increases, what will happen, the concentration will decrease. Okay, the concentration will decrease linearly. Okay, so at, so concentration of A at time t, that is concentration of A naught minus kt. Okay, so the time required, whatever the time required for the zero order reaction to complete. Okay, so at time t it will be 0. So time of completion, it will be what, it will be a naught by k. Okay, a naught by k, or it will be a naught is nothing but your initial concentration which is given by a. So so this is your answer, so option number C. Okay, so the concentration of completion. So we know that what will happen at zero order reaction. Okay, so as the time increases, the concentration will fall to initially. Okay, linearly it will decrease. Linearly the concentration will decrease. So at time t, okay, so the time required for the zero order reaction to complete, it will be what, at time at. Okay, at the concentration of t will be at a naught 0 minus kt. So the time required for completion will be what? A naught by k. Okay. So t. So because at will be 0. So after resubstituting, you are going to get t is equals to a by k. Okay. So the answer is what? It is C. Option number C, a by k. So the time required for 100% completion of zero order reaction is a by k. Initial concentration by rate constant. Okay. Next question. A first order reaction is 60% complete in 20 minutes. Okay, a first order reaction is 60% complete in 20 minutes. How long will the reaction take to be 84% complete? This is very important, such questions. Okay. Our first order reaction is 60% completed 20 minutes. Okay, how long it will take to complete the reaction, for that is to take the reaction to be complete 84% complete. For in 20 minutes 60% it is completed, and they have asked how much time it will take to complete 84%. 84% to complete. Yes. So A 54 minutes, B 68, C 40, and D 76 minutes. For 60% to complete, it is taking 20 minutes. Okay, in 20 minutes, 60% reaction, first order reaction is completed. So how much time it will take to complete to be 84% complete? Yes, how you are going to solve this? So if we take the initial concentration, okay, the initial concentration is 100. Okay, then the concentration of A will be what? 100 minus 60. Okay, that is 40. Okay, 40 in 20 minutes. Okay, 40 in 20 minutes. So rate constant that is given as K. Okay, which will be 2.303 T log of A naught by A, concentration of A. Okay, so K is equals to what? 2.303. What is the time taken? 20 minutes. Okay, for 60% for completion. So log of what is the initial concentration is 100. What is the this? It is 40. Okay. Uh, so, so what you are going to get, K is equals to 2.303. Okay. Then time taken is 20. So time taken is 20. Then log of 40, 100 by 40 is 100 by 40 is 2.5. Okay. So log of 2.5, you see, log of 2.5 is 0. So it will be 0.397. Okay, 0.397. So it will be, so this is the first equation what we have got. Log of 100 by 40 is 0.25. Then you take 100 by 40 is 0.25. Then take log of 0.25, which is 0.397. So this is the first equation. 2.303 divided by 20 into 0.397, okay, per minute, okay, per minute. So this is the first equation. Now we will see the time for 84% completion of the reaction, okay, 84% completion of the reaction. So for 84%, again, so time taken for 84%, so time taken for the 84%, it will be what? 2.303, okay, by K, because what we are finding, we know time, okay, we have to find time, we know the rate constant, we have rate constant here, right? We have found out the rate constant in the above equation, so that we will substitute into log of, so the initial will be 100 and the time taken, this will be 100 minus 84. Now what we will do, we will substitute this, okay, the value of K here. So what it will be, 2.303, okay, into 2.303 into K is what? K is 2.303. So this will be into, and this will be 0.397 log of 100 by 100 minus 84 is how much? 16. Okay, 100 minus 84 is 100 minus 84 is 16. Yes, 16. So divide 100 by 16 now. 100 divided by 16, 6.25. Find out log of 6.25, 0.79. Okay, so log of, not log of. So I've got log of 6.25 is 0.795. Okay, so now what will cancel? So this and this will get cancelled. So 20 by 0.397. 20 divided by, so we'll keep like that only, beta. So 20 divided by, so what I am going to get, 20 divided by 0.397 into 0.795. Okay, into 0.795. So 20 divided by 0.397 is how much? 50. Okay, 50.377 into 0.795 into 0.795. How much you are getting? I got 40.05 minute. How much you have got? Option number C. How much you have got? C. So very important such questions. Okay. First order reaction, it completes so much that they will tell you what to complete 84%, how much time it will take. Okay, like that. These type of questions are very important. So I hope this is clear. Okay. Should I explain it once more? Yes, Lubna has got it as 40. Should I explain it once more? So what all we have done? So we have written the given things, initial concentration, the final concentration, time taken. So this is, so what we have done? We have calculated the, we have written the rate constant K is equals to 2.303 by T log of A naught by A naught by A. Okay, concentration of A naught by concentration of A. Then put the values. Okay, everything is given 2.303 by T. Okay, log of T is what? T is 20. Okay, time is given, that is 20 minutes. So let it 2.303 by 20 log of initial is 100, final is 40. So 100 by 40 is 0.25. So find out the log of 0.25, that is 0.397. Okay, so and so this 2.303 by 20. Okay, so after so this is the first this is what we have got. Now second, from the second this we have to find the time taken. So time, so 2.303 K we have substituted rate constant here, and T we have shifted here, just vice versa. Put the values 100, 100 minus 84. Okay, put the value of K which we have got from here. Okay, after substituting we are going to get what? 20 by 0.397 into 0.795. Okay, which is 50 into this, which we got final after substituting is 40. Okay, so like that we are going to get the answer. Okay, very, very important. I hope this is clear. Okay, so very simple. Just don't get confused in the. Okay, is it clear up to here? Okay, so let us go for the next one. A given sample of milk turns sour at room temperature in 5 hours in a refrigerator at minus 3 degrees Celsius. It can be stored 10 times longer. The energy of activation for the souring of milk is. So these are the four options which is given. Okay, so a given milk is it has got sour. Okay, at a temperature at a room temperature. Okay, in 5 hours it has got sour. So the refrigerator in a refrigerator at minus 3 degrees Celsius, it should have stored 10 times longer. So what will be the energy of activation for the soured milk? So how you are going to find the energy of activation? How we are going to solve this? So what all is given, we will write first. Okay. So rate of souring of milk at 27 degrees Celsius, okay, is what? 10 times faster than minus 3 degrees Celsius, right? So at room temperature, what it is getting at in 5 hours. Okay, it may get spoiled. The milk will get sour in 5 hours. But your this okay in your refrigerator it is 10 times faster. Okay, in the refrigerator it is 10 times faster. So what is the energy of activation they have asked? So we will find out the energy of activation, hence energy of activation. So the rate of this at 300 by what is the at room temperature means 273 plus 27, 7. So your T1 will be your T1 will be your T1 will be 270. T2 will be 300. Okay, so minus 3 degrees Celsius. Minus 3 degrees Celsius means 270 273 minus 3. Okay, so that is 270. Okay, your T1. So your T1 will be 270 and your T2 will be 273 plus 27. That is 300 degrees Celsius. So this will be 270, 270. Okay. So the rate of this at rate of energy of activation at 300 by 273. Okay. So that is given as 10. Okay, 10 times faster. So T1 is 270, T2 is 300. Right. So this is the given information. Now let us find out the energy of activation. This is a formula 2.303 R. Okay, T1 by T1, T2 into T1, T2 minus T1 into log of K by 100, K by 273. Find out, put the values, everything is given. Find out and tell me the answer. Find out and tell me the answer. Yes, find out, put the values. Okay, everything we have solved. Yes, what is the answer? Sri Varuni has answered it as D. Okay. Others? So after solving, okay, T1 you have to put 250, T2 300. Okay. Then log of K 300 by 270. Okay, it will be how much? 300 by 270. So you're going to get your log of 10. Okay, solve this. Activation energy, what I am getting is 2.303, okay, and into 2.7 into 2.7 R kilojoules per mole. So option number D. Option number D. Okay. So a given sample of milk turns sour at room temperature. Room temperature means 273 plus 27, that is 300. Okay, in 5 hours. But in the same, okay, the milk can turn sour in the refrigerator at minus 3 degrees Celsius. That is 273 minus 3, that is 270. And it can be stored 10 times longer. So the rate constant, okay, is of 300 by 270 is 10. Okay. So you have to find the energy of activation. We know the formula, that is EA is equals to 2.303 2.303 K T1 by T2 T1 T2 T1 T2 okay, T2 minus T1 T1 into T2 divided by T2 minus T1 log of K by 300 and K by 270. Okay, so after solving this, I am going to get the energy of activation, okay, as 2.303 into 2.7 R kilojoules per mole. Okay, so option number D is the answer. Option number D is the answer. Fine. Okay. Same question. Okay. If 50% of the reactor is converted into product in a first order reaction, okay, in 25 minutes, how much of it would react in 100 minutes? Now, okay, previous question, how it was, they had asked you the time. Now they have asked the uh, percentage, how much it has reacted in 100 minutes. Okay. So find out the concentration, how they have asked. Find out. So if 50% of the reactant is converted into product in first order reaction, okay. So how much it would react in 100 minutes? How you are going to solve this? So 100 minutes So 50%. 50% means what? T half. Okay. So half-life is how much? So half-life is 25 minutes. So T half is what? T half is 25 minutes. Okay. It is for 50% means half of the reaction is completed. Right. So it is T half. So T half of the reaction is 25 minutes. Now from 100 to convert into 50, it has taken 25 minutes. Okay. Now 50 to again convert into 25, again it will take 25 minutes. Right. Again from 25, its half is 12.5. It will take 25 minutes. Okay. Then again to complete 12.5 to 6.25. Okay. It will take 25 minutes. So how much is remaining? So 25, find out. So 100 minus 6.25 is 93, 93.75. Okay, so 100 minutes. So 25, 25, 25, 25. So after 25 minutes, okay, how much it has reacted is 93.75. So 93.75 has reacted. So that is A, option number A. Okay, so again once we will see. So if 50% of the reactant is converted into product, okay, 50% of the reactor is converted into product in the first order reaction in 25 minutes. 50% means T half. Okay, so T half of the reaction is 25 minutes. So 50% is completed. Okay, half of the reaction is converted into product. So for 100 minutes, how much? Now for 100 minutes, the half 50% is how much? 50. So it has taken 25 minutes. Now they have asked what for 100 minutes. So let us calculate for 100. 50 half is how much? 25. So it has completed again 25 minutes. Okay, because 50% again 25. What is the half of 25? Is 12.5. So to complete again half of the reaction, it has taken again 25 minutes. Then to complete half of 12.5, that is 6.25, again it has taken 25 minutes. Okay, so after 100 minutes. So this is after 100 minutes, how much has reacted. So after 100 minutes, how much has reacted? Okay, how much has left is 6.25. So minus this 100 minus 6.25 is 93.75. So this much has been reacted. So option number A. Is it clear? Is it clear? Very important. Okay. Is it clear? Okay, let us go for the next one. The rate of the reaction increases with rise in temperature because of the rate of reaction increases with rise of temperature because of A, increase in number of activated molecules, B, increase in energy of activation, C, decreasing energy of activation, and D, increase in the number of effective collisions. The rate of reaction increases with rise in temperature because of what is a factor because of which the rate of reaction is increasing with the rise in temperature. As the temperature increases, the rate of reaction also increases. So what is the factor which is responsible for the rate of reaction to increase? There are two effects. Okay, increase in temperature, what will happen? The collision intensity will be more. Okay, so what will happen to the number of activated molecules? And there will be, because of that, there will be more number of activated molecules and effective collisions will be more. So increase in number of activated molecules and increase in number of effective collisions. So as the temperature increases, what will happen? There will be collision frequency will be more. Okay, collision intensity will be more. So because of that, the number of activated molecules and more frequent collision will be, you can see, okay, the number of effective collisions will be more. So A and D, both are the correct answers. Okay, A and D, both are the correct answers. Increasing energy of activation, no. Decrease in energy of activation, no. Okay, increase in number of activated molecules and increase in number of effective collisions. So A and D, both are the right answer. Okay. The temperature coefficient of a reaction is 2. When reaction is increased from 30 degrees Celsius to 90 degrees Celsius, the rate of reaction is increased by. How the rate of reaction is increased? We know that rate of reaction is doubled for every 10-degree rise in temperature, right? We know that. So for every 10-degree rise in temperature, rate of the reaction is doubled. So what will happen when the temperature goes by 60 degrees Celsius, right? When the temperature goes to 60 degree temperature, what will happen? So temperature will raise by what? 2 raised to 6 times, right? Because for every degree rise of temperature, okay, 10-degree rise of temperature. So 60 times, right? 30, 90 minus 30 is how much? 60. So 60 degree is increased. So it is 6 times increase. So 2 raised to 6. What is 2 raised to 6? 2 raised to 6 is 64 times. So it has raised by 64 times. Option number B. Okay, so for every degree rise of temperature, the temperature is raised by the temperature. Okay, you can see the rate of the reaction is doubled at 20 at every 10-degree rise in temperature. So now here the temperature is raised from 30 to 90. So 90 minus 30, how much has raised? It is 60 degree. Okay, so 60 means what? 6 times, right? 6 times. So 2 raised to 6 is 64 times. So option number B. Is it clear? Is it clear up to here? Yes. Okay. So these were some of the questions. Okay. So there are many questions, still more questions. Okay. Different types of questions. So that we'll be discussing in the next class. Any doubts up to here? Okay. Little confusing, but very interesting questions they are. Okay. Little lengthier, but very interesting questions these are. Okay. Any doubts up to here? Fine. So the remaining questions we shall discuss in the next class. Okay. Fine. So thank you. I'll end this session here. We'll meet in the next class.